In Lesson 10.5, you will find probabilities of independent and dependent events. Two events are independent if the occurrence of one has no effect on the occurrence of the other. If A and B are independent events, then the probability that both A and B occur is given by this equation. Probability of A and B is equal to the probability of A times the probability of B. In example 1, in a survey at a football game, 50 of 75 male fans and 40 of 50 female fans said that they favor the new team mascot. If one male and one female fan are randomly selected, what is the probability that both favor the new mascot? Well, the probability that the male selected favors the new mascot is 50 of 75, so 50 over 75. And so we're going to multiply, and the probability that the female selected favors the new mascot is 40 of 50. So the successes there are 40 and the possibilities are 50. So we multiply to get our probability that both the male and the female favor the new mascot. So simplifying that first fraction simplifies to 2/3. The second fraction simplifies to 4/5. So when I multiply, I get a product of 8/15. And that's our probability. In example 2, a survey found that 46% of parents surveyed say that they read to their children at least once a week. If 3 parents are selected at random, what is the probability that all 3 will say that they read to their children at least once a week? Well, the probability that the first parent selected says that they read to their child at least once a week is 46%, or 0.46 probability. The probability that the second parent selected says the same thing is another 46%, or 0.46 probability. And that the third is also 46%, or 0.46 probability. So we're just multiplying these three probabilities together. So it's just 0.46 raised to the third power. That's what I'll put in my calculator to approximate this probability. And this probability then approximates to 0.097 rounded to 3 decimal places. So a 0.097 probability that 3 parents selected at random will say that they read to their children at least once a week. In example 3, during each of the 5 days of a special week, an employee is randomly given one of 10 prizes. All prizes are available each day, and one of the prizes is a $500 gift certificate. What is the probability that an employee receives the $500 prize at least once? Well, to satisfy at least once, one employee could receive the prize, the $500 gift certificate. 2 could, 3 could, 4 could, or all 5 winners could receive this $500 gift certificate. So rather than considering all 5 separate probabilities, let's use the complement. Let's find the probability 1 minus the probability that no employee receives that $500 gift certificate. So that's going to equal 1 minus. Now the probability that the first winner doesn't receive the $500 gift certificate is 9 over 10. 9 successes, not including the $500 gift certificate, out of 10 possibilities. The second day, the second winner has the same probability. The third day, the same probability. The fourth day, that winner has the same probability. And the 5th day, the winner will have the same probability, 9 successes out of 10 possibilities. So we're just going to put in our calculator 1 minus 9/10 raised to the 5th power and approximate this probability. And I'm getting 0.410 for a probability that at least one employee wins the $500 gift certificate. Two events are dependent if the occurrence of one affects the occurrence of the other. The probability that B will occur given that A has occurred is called the conditional probability of B given A and is written using this notation. If A and B are dependent events, then the probability that both A and B occur is given by this equation. The probability of A and B is equal to the probability of A times the probability of B given that A has happened. In example 4, the table shows the status of 200 registered college students. What is the probability that a randomly selected student is female? Well, in A, since there's 200 possible registered college students to choose from, and we want the success to be a female, and the females total 80 plus 40. So our probability is 120 over 200. Getting rid of a factor of 10 top and bottom, and then a factor of 4 top and bottom, our probability is 3/5. There's a 3/5 probability that a female student will be selected, randomly selected from the 200 college students. Then in B, what is the probability that a randomly selected student, if female, is a full-time student? So now these are dependent events. It's true that a female had to have been selected, so now our possibilities are down to that 80 plus 40, or 120 possibilities. Now we want the success to be a full-time student, so of those 120 female students, 40 are full-time, so that's our successes. And now simplifying here, we can get rid of that factor of 10 again and a factor of 4 top and bottom, so we get 1/3, a 1/3 probability that if female, the student selected is a full-time student. In example 5, you randomly select 2 cards from a standard deck of 52 cards. What is the probability that the first card is a heart and the second is a club if you replace the first card before selecting the second? So in A, with replacement, our successes for getting a heart are 13 out of those 52 cards in that deck. And so we're multiplying. There are 13 clubs in that deck. We replace the heart, so there's still 52 possibilities. So to get this probability, we'll multiply. So this is 1/4 times 1/4, or a probability of 1/16. That first you select a heart, replace, and then select a club. Okay, in B, what is the probability that the first card is a heart and the second is a club if you do not replace the first card? Well, now selecting a heart, our successes are 13. There's 13 hearts in this deck of 52. But now we're not going to replace that heart. So our possibilities are now 51. There's 1 card less in that deck. And our successes, since there's 13 clubs, would still be 13. Okay, so simplifying here, 1/4 times 13/51, and then multiplying is going to give us a probability of 13 over 204. So 13/204 probability that you will select a heart and then a club if there is not replacement. In example 6, suppose your area has 8 different internet service providers and you and 3 friends randomly select your own ISP. What is the probability that you all choose different ISPs? You and 3 friends, so that's 4 total people. Now you are going to select first, and you have 8 choices from those 8 ISPs. Now the next person to select can't choose what you chose, so they have 7 successes out of the 8 possibilities. Then the next person has 6, out of the 8 possibilities, and the fourth person has only 5 left, so that they do not choose the same as the other 3. Okay, so simplifying and multiplying here, we can cancel a factor of 2 top and bottom. Okay, nothing else cancels. So let's multiply using our calculator. So in the numerator I'm getting 105, and in the denominator I'm getting 256. Now if we want to use a decimal form for this probability, we can divide 105 divided by the 256. And rounding to 3 decimal places is 0.410. That's the probability that you and 3 friends will randomly select your own and different ISP. In example 7, on a manufacturing line, 20% of all the items produced are defective. Although all the items are inspected before they are shipped, 10% of the items are incorrectly classified as either defective or not defective. What percent of the items will be classified as not defective? So let's make a little tree here. 20% of all items are defective. That means that 80% of all items are not defective. Now of those 20%, when they go out, 10% are incorrectly marked or labeled, and 90% are correctly labeled. Okay, same thing with the 80% that are not defective. 10% are incorrectly labeled, and 90% are correctly labeled. So if we want the percent of items classified as not defective, we'll start with our 20% that are defective, and 10% of them are incorrectly labeled, so we'll multiply by 0.1, or, so we're going to add when we say or 80% are not defective, and 10% of them, 90% of them are correctly labeled, so we'll multiply by 0.9. So this sum will give us the percent of items that are classified as not defective. So I'm getting 0.02 when I multiply, plus 0.72, and when I add, I get a percent of 0.74. So 0.74, or 74% of the items are classified as not defective. Include with your notes of this video guided practice problems 2 through 8 even on pages 718, 719, and 721 of your textbook.